Hello friends, I welcome you in lecture number 24 on partial derivatives. In this lecture, we are going to discuss about method of Lagrange multipliers. We will see that when we can apply Lagrange multipliers method to find out the maximum or minimum values of given function. So for Lagrange method, for example, if we consider this problem, suppose we want to find maximum values or find maximum and minimum values of fxy equal to xy on the circle x square plus y square equal to say 9. So I am considering two questions here. One question is find the maximum and minimum values of fxy equal to xy on the circle. Another question is find maximum and minimum values of fxy equal to xy. So you can understand the difference between these two questions. Here we are asked to find out the maximum and minimum values of fxy equal to x into y, and here we are asked to find out the maximum and minimum values of fxy equal to xy, but with some restriction. We have to find out maximum and minimum values on the circle. That means the points at which function is maximum or minimum must be points on the circle. We are having circle with center, origin and radius 3. For example, suppose this is the circle with center, origin and radius 3. Suppose this is the center, this distance is 3. Now on circle there are infinite number of points. Okay, we can have infinite number of points on the circle. So out of these infinite number of points on the circle, we have to decide the point on the circle at which this function is maximum or the point at which this function is minimum. So here we have restriction on the points xy. These points xy must satisfy this equation x square plus y square equal to 9. Or we can say that these points xy must be on the circle. So we are having some restriction, or we can say that we are having some constraint. Constraint, another word is restriction. So if we are given some restriction in the problem of finding maximum and minimum values, then we will apply the method of Lagrange multipliers to find out the maximum and minimum values of given function subject to the constraint or subject to some restriction. So in this case we have to find out the points on the circle x square plus y square equal to 9 at which this function is maximum, and we have to find out the points on the same circle at which this function is minimum. So in short, whenever we are considering fxy, then this xy must satisfy this equation, or this xy must come from the circle at which function is maximum or minimum. In this problem there is no restriction. We have to find out maximum and minimum values of fxy equal to x into y. So here there is no restriction on the values of xy. Your point xy can be any point from the xy plane. So if there is no restriction in the problem of maximum and minimum values, we will apply earlier method which we have discussed in earlier 4 or 5 lectures, that is second derivative test. So we can find out answer to this question using second derivative test. But if we have this type of problem, find maximum and minimum values of some function subject to some condition, then we will apply method of Lagrange multipliers. So for Lagrange multiplier, structure of our problem will be like this: maximize or minimize function f. Your function can be function of 3 variables also, subject to the condition or subject to the constraint, which will be given in this form: some function of xyz equal to 0, or you can write some function of xyz equal to some constant k. So we will use this restriction in finding maximum and minimum values of f of xyz. Now from the given problem, you have to decide what is your small f and what is your small g. The function which you want to maximize or minimize will be considered as small f, and the function g will come from the restriction. So now how to find out the maximum and minimum values of f of xyz subject to the condition g of xyz equal to 0. So for that we have method of Lagrange multipliers, and this is very easy method. So what is method of Lagrange multipliers is, first step is decide what is small f and small g. Small f is that function which you want to maximize or minimize, and small g is the function which comes from the given restriction. For example, in this problem, here we are asked to find out maximum and minimum values of x into y. So this is our small f, and here restriction on the points x, y is x square plus y square equal to 9. So we will consider gxy equal to x square plus y square minus 9, or we can ignore this constant. We can simply write gxy equal to x square plus y square. So first we will decide f and g. After that we have to solve the system of equations. So that system can be linear or it can be non-linear. So solve the system of equations. Remember this system is given by gradient of f equal to lambda times gradient of g, and another equation we will use is the equation which is specifying the given constraint. So we have to find out this system of equations. In this system of equations, variables are x, y and z if we have 3 variables. If we have function of 2 variables, variables will be x, y, z, and we have one new variable lambda, that is known as Lagrange multiplier. So we will solve this system of equations in 4 variables x, y, z and lambda. We will not require value of lambda every time, but sometimes we will find out value of lambda to obtain the values of x, y and z. Now if function is of 3 variables x, y and z, then by the definition of gradient we can write gradient of f equal to del f by del x, del f by del y, del f by del z, and gradient of g is del g by del x, del g by del y, del g by del z. So this we can simplify. First we can rewrite right hand side by multiplying each component by lambda, lambda times gx, lambda times gy, lambda times gz. Therefore we obtain 3 equations by comparing corresponding components. Del f by del x equal to lambda times gx, del f by del y equal to lambda times gy, del f by del z equal to lambda times gz. So we obtain 3 equations by solving gradient of f equal to lambda times gradient of g, and we have to use this equation also. So we have system of 4 equations, gxyz equal to 0. So in every problem we have to find out values of x, y, z and sometimes lambda which satisfy these four equations. Our aim in Lagrange method is to find out the points in the form of triple x, y, z which satisfy these equations number 1, 2, 3 and 4. And here lambda is known as Lagrange multiplier. After finding out values of x, y, z satisfying these equations 1, 2, 3 and 4, we will find out value of function small f at all these points. Whatever number of points we obtain here, we will decide the value of function f at each of these points, which are the solutions of this system. So there will be finite number of points after solving these systems. So whatever number of points we will obtain, we will find out value of f of x, y, z at those points. Now the point at which function is maximum, that will be the point at which function is maximum, and we will find out the point at which function is minimum. So in that way we can decide the points x, y, z at which function is maximum or minimum, and we can find out the maximum and minimum value by finding value of function f at that point. So the main thing in Lagrange method is we have to solve this system. It is not easy to solve this system because this is a non-linear system most probably, and non-linear systems are not easy to solve. So our main focus is in solving equations number 1, 2, 3 and 4, and there is no general method for solving these equations 1 to 4. The method will differ from problem to problems. So we have to solve as much problems as we can do to master this method of Lagrange multipliers. But there are some limited problems which are being asked frequently in GTU exams. So we will focus on those type of problems so that we can easily understand this method. So in this lecture we have discussed what is method of Lagrange multiplier. We will apply the method of Lagrange multiplier if we have this type of problem. Suppose we want to find out maximum or minimum values of function f of x, y, z subject to the constraint g of x, y, z equal to 0 or g of x, y, z equal to k. So if our problem has structure of this type, then we can find out the solution to this problem using method of Lagrange multiplier. So first we will decide what are the functions f and g. Function g will always be decided from the given restriction or constraint. After that we will remember this system. We will solve the system of equations in three variables x, y, z. Gradient of f equal to lambda times gradient of g with this equation of restriction or constraint. If we have functions of two variables, then we will have three equations. We will not have this equation if we are having function of two variables, but method is same. So main thing in Lagrange method is how to solve this system of four equations in x, y, z and lambda. If we can solve this system, then we will obtain some points. After that we will find out value of function f at these points. So the point at which function is maximum is the point of maximum, and the point at which function is minimum is the point of minimum value. So in this way we can apply Lagrange method of multipliers to find out the maximum and minimum values of given function subject to the given condition. So here I have written this. Suppose that f of x, y, z and g of x, y, z are differentiable. Suppose we want to find the local maximum and minimum values of function f subject to the constraint g x y z equal to 0. This is the structure of problem in which we will apply method of Lagrange multipliers. Now method is simple. Find the values of x, y, z and lambda that simultaneously satisfy the equations gradient of f equal to lambda times gradient of g and g x y z equal to 0. For functions of two independent variables, the condition is similar but without the variable z. So this is all about this session. In this session we have discussed method of Lagrange multipliers. In upcoming lectures we will discuss different problems related to this method. So I stop here. Thank you.